for no reason. Okay. So this equation, the parabola that's formed by this one, is going to model the path of that ball, but not perfectly, right? Not perfectly. How so? Well, let's type this in. Where h of t is the height in feet and t is the time in seconds. So we know that it's comparing time and height. So let's go ahead and try to graph this and see what we get. Not bad. Whatever window I happen to have works pretty good here. But let's say you don't. Let's say you did homework, your window is way off. My first go-to would be Zoom Standard. Zoom Standard doesn't really work very well. So Zoom Fit. Okay, here's what I'm going to talk about Zoom Fit. It helps you to find a parabola, but I don't need to see the negatives here. I really don't. Okay, so if you're like me right now, I'm going to change my window. The X-min, I'm just going to go slightly to the left of it, so -5. I'm going to leave X-max as 10. Y-min, watch this. Y-min, I'm just going to go slightly under because I want to see the X-axis. So my Y-min, I'm going to also set to -5 or -10, whatever the context gives you. Y-max, I'm going to leave it because I was seeing the vertex there, but maybe let's go 70 just to see a little bit past it above the vertex. So this is what I'm using. I'm going to hit graph. Let's see what it looks like. It's a pretty good graph. It's a pretty good graph. So if you see it, you're fine. Okay, that's all I'm going to say here. If you see it, you're fine. All right, so let's make some observations here. H of t, this is your y, and this is your x, right? That's what you need to know. Like whatever is over here is always the y, and the variables that follow are your x variables. So every single point on this parabola is going to be time followed by the height. Okay, so if you plug in a time, you can find the height, or if you plug in a height, you can find the time. That's how it goes. That's basically what most of these questions are about. Okay, so A, what is the initial height? The initial height is important wording here, of the trajectory of the ball. What is the height? Or another way of asking is, at what height was the ball hit? Okay. Initial height is given by the y-intercept. Okay. It happens at time 0 seconds. Okay. So from here, we can say that the y-intercept is 0 what? 0.4. Can we say that? Can we use the last? We can, because it's in general form, right? So that 4 is my y-intercept. So the y-intercept gives me the initial height. Therefore, the initial height, please don't leave it like that. A lot of students just give me the 0.4. You're very close, but you're not quite there. It is just this, 4 feet. Is 4 feet. Okay, this is the number that you want to state. It's time 0. So at the very beginning, you are at a height of 4 feet. Okay, so that's important there. Don't just give me the point. Actually tell me what the height is. Mr. Dirksen, could I have used second trace 1, x is equal to 0? Absolutely. I just felt like it's quicker this way. Determine the maximum height of the ball. Max height is given by the vertex. Okay, there I'm going to use the calculator. So I'm going to say second trace. We know this is pointing down even before we graphed it, right? So I'm going to find the maximum. I'm going to use second trace maximum to make that happen. So you grab your calculator, and I just type second trace max. Very important. If you do min, it's not going to find it. It's going to try. You won't know that you're not finding it. You'll think, oh, that is the one, right? But look at your cursor. Your cursor should be ending up where the vertex is. Okay? So there it is. Write it down exactly the way it is to 2 decimals. For me, it's 3.57, 66.5. That is the vertex. Therefore, the max height that this ball will reach is, which of the two is it? It's height. Remember, we've determined that way up here. I'm just going to show you one more time. At the very beginning, I determined that the x values represent my time and the y values represent my height. So the max height is 66.5 feet. Done. C. How long does it take for the ball to hit the ground? In other words, how long does the ball remain airborne? Oh, you can't see that there. Right? This is the question I'm answering here. So I'm asking a lot of questions. I won't be asking this many on a test, but it could be any of these that I will ask you for. So this is given by the x-intercept. Okay, that's what this is. So I'm going to use second trace. Oh, I forgot something. Y2 is equal to 0, right? I'm assuming, I bet, Y2 is equal to 0, and then I'm going to go second trace intersect. And I will just mention something here. I'll make a little sketch here. Okay. Because this is a word problem and because we have a context that tells us, we're assuming that this is what happens, right? You see this on our screen. The calculator doesn't know that we start here and we stop there. The calculator doesn't know this is a baseball question, right? So this one, watch this. I'm going to make this a dashed line. This x-intercept we omit this one, right? We do not include that x-intercept. We would not be including that. We would just be looking for this one. This one is outside of what we call our domain, okay? So don't be using that. Only state this one. Only state the positive x-intercept. There will be some instances where you go into the negatives, but we'll talk about that later. Okay, so we plug this in. Let's go and do this. Y2 is equal to 0. I'm going to hit graph. And maybe, let's see, it could be, I can see you on a test being like, wait a minute, that looks awfully close to 0. Let's try it. Right now, it's going to find that one. And that one is close to 0, but it is negative 0.11. We would not be using that one. Okay. And I think a lot of you are like, yeah, I get it. It's this one, right? Because it's launched and it hits the ground right there. So enter, enter, enter. That's 7.26 rounded. 7.260. It takes 7.26 seconds for the ball to hit the ground. Okay, there we have it. D. What does D say? Calculate the height of the ball 1.5 seconds after being hit. So basically, if time is 1.5, then what is the height? That's what it's asking. So we would go second, trace, value, and you let x equal to 1.5. Okay. So let's figure out what the y value is there. Second, trace, value, x is equal to 1.5, and there it is. After 1.5 seconds, it's at a height of 45.48 if you round it to 2 decimals. Okay, so that's 45.48. And if you put feet in, we are happy, right? So that's the height of the ball after 1.5 seconds. E. Determine the ball remains at or above 49 feet. Here's where I want you to pay close attention. This is where it's not just find the point and state it. Let's sketch it here. I'm going to give you a sketch. We know we're 4 feet above the ground, right? So this sketch should not start right at the origin. It should start slightly above, okay? So we're going to go and get our maximum height, and then we do hit the ground. Now, we want to know how long this ball stays at or above a height of 49. What I will ask you to do is, we're going to go y2 is equal to 49 feet. Let's do that. Let's type in 49 feet into our, because remember, they basically give you a y value, and they want the x values for that. Type in y2 is equal to 49, and then hit graph. And you see, hey, that is the 49 height, right? You see that. So we will do the same on in our sketch here. This, we will assume this is our y is equal to 49. Okay, that is our 49 feet mark. So what you need to do is, what they're asking us for is from here to there, right? How long did it take? How long was the ball at 49 or above it? That's what they're asking for. Okay. So what we're going to do is we're going to go y2 is equal to 49, and then we're going to go second, trace, intersect. And we're going to find both of these values, and we're going to write them down here. But make sure you state them to 4 decimals, because we're not done yet. We're going to do something with those numbers. So you go ahead and do that. Second trace 5. I'm already close to the first one, so I'm just going to hit enter. And I'm going to write down 1.6816, 4 decimals. And then I'm do it one more time. Second trace 5. Go to the other side. Enter, enter, enter. And that is 5.4613. 4 decimals, right? I will say use 4 decimals. This question will be worth 2 marks. When you see 2 marks, you're like, oh, this is going to be more than just finding the 1 point. Okay. So to find the difference, like the difference in time that passed by here, we're going to go like this. we call it delta t, is going to be time 2 minus time 1. Delta means difference or how much time has gone by. So time 2 is the higher number minus the lower number. And if you calculate that, that is 3.78 seconds. Okay, this is the answer. Delta t, when you subtract, you find the time it was at or above. At or above 49 feet. And this question doesn't ask for it, but I will ask you anyways. What if this had said time below 49 feet? What if I asked you, hey, well, if you know how much time was spent above that, at or above 49, how much time did it spend below? So we're interested in these sections right here, this one and this one. The easiest way to do it is we just go 7.26, that's the total time. Remember, that was our total time the ball remained in the air. Right here. We're going to subtract 3.78 from it. And that is 3.48 seconds. It's very close. They're very close to each other. I should have probably picked this is below 49 feet. Let's give this a different color and then go and do that on our. So this is the time. If we were to add up the time spent here and there, you would get 3.48 seconds. And this one, I'm going to highlight this with the orange color. This is the most frequently used of all, that one. The orange one is the one that, like delta time, where you find above, at or above, is usually the more frequently used. And I may have to add something to your notes on that later to help you out. I'm going to just highlight, use 4 decimals here. And we will sketch this now. Graph it, not sketching. We're going to graph this now with all that information that I just collected. We're going to graph this on the back side of this. I wish I could have fit it on here. Maybe I should have put it on 35, but it is what it is. I'll just help you out with the numbers. So let's go to 37. If I ask you to graph, remember the scale, your intercepts, your vertex, your label, your axes with name and units. I forgot to write down equation. Don't forget your equation on this thing. And I kind of helped you out with this grid. So arrowheads on the axes here. I'm going to write down my important points. The x-intercept I'm interested in was 7.260. The y-intercept is 0.4. I'm just copying from the previous page. Vertex is 3.57, comma 66.5. Those are the points I must have on here. I look at my x-intercept to determine my domain, right? I need to go all the way to 7. So if I go back down here, I'm going to try 1, 2, 3, 4, 5, 6. It's too short. Okay. I'm going to try going up by 2. So 2, 4. Clearly indicate where those numbers belong. Like make a little mark so that I know, okay, that's where you mean to put the 6 and the 8. And the spacing is equal, right? So you go up, if you choose to go up by 4 boxes, that's fine with me. In terms of my highest Y value, I need to make sure I fit in 66.5. So I'm going to try something here. 20, 40, 60, 80. That works pretty good. So I'm going to go 20, 40, 60, and 80. So I've got my scale down. You could have picked a different scale, 15 at a time. It's up to you. Don't forget time as well as seconds goes along the x-axis. Don't do this last. Do this right away. Time and seconds. And then this will be height in feet at the top somewhere. And now we can graph. So plot your points. 0, 4, this is 10 right here. This is 5. So 0, 4 is just under the 5 line. It's right there, 0, 4. 7.26, this would be 7 right here. Between 6 and 8, this would be 7.5. I need to be just shy of 7.5 right there. The vertex, 3.57. So this would be 3, this is 3.5, this is 3, this is 3.5. So I'm going to go up the 3.5 line and try to find 66.5. This is 70, this is 65, 66 is right about there. Just a dot like that. And then I go to my vertex, I go out and down, I go back to my vertex, I go out and down there. And my equation, that's a full, potentially 3 out of 3, 2 out of 2. I just want to finish with the domain and range. I think domain and range is G. So G, domain, and range. What would be your domain here? Time starts at 0 and it stops, like the action stops when it hits the ground. So that's the 7.26, right? So that's where it ends. For my range, I go as low as 0 because I do hit the ground. This ball does hit the ground. Sometimes I will have examples where it lands on something and it just stays there. And the highest is 66.5. Boom, there's your domain and range. I'm coming back, hold on. I will do I here and I will leave the other one. Let's read I before we go. Sometimes I'll ask you to write another equation that would model the path of a ball with a lower maximum height. A lower maximum height. Stay with me because so basically, example, decrease the value of C. That's all you need to do. So if I go, well, this is another ball that was hit, I will copy everything the way it is. However, the C value, I'm going to give it a different color. You could go +3. And you're like, how so, Mr. Erickson, how so? If you grab your calculator, maybe you don't have time for this, but I will show you. If I were to copy the exact equation from before and type it into Y2 and graph them at the same time, do you see that was slightly lower? It's maybe not as obvious. Maybe I should go +1. Right? Like the lower this value, the shorter your curve becomes. It actually shifts everything. We'll talk more about that tomorrow. What I want you to try for homework, I want you to try just two questions I'm going to assign.
Please excuse the interruption, but we have a huge congratulations to the JV boys basketball team for winning the provincial championship last night. It was a game full of super highlights.
I just want to add something. I found an old video. It's from 2022. I actually worked through 38 to 41. I will post it. I only want you to do these two. I don't want you to do all four because it's a bit much. These two. So if you're stuck, like you just stuck, maybe check that video out and see if it helps you. I worked through all 4 pages. You just need to do 2, okay? Have a good one, guys.